Download this code from codegive.com, link in the description below. Calling external APIs in SAP abap using API keys and REST APIs, a detailed tutorial. This tutorial provides a comprehensive guide on calling external APIs from SAP abap, focusing on using API keys for authentication and interacting with RESTful APIs. We'll cover the essential concepts, necessary abap classes, coding examples, error handling, and best practices to ensure a smooth and secure integration process. 1. Understanding the concepts ****. REST APIs, representational state transfer. REST is an architectural style for building networked applications based on standard HTTP methods, GET, POST, PUT, DELETE, to access and manipulate resources. REST APIs are stateless, meaning each request from the client contains all the information the server needs to understand and fulfill it. **API keys. *API keys are unique alphanumeric strings used to authenticate requests to an API. They act as a form of identification, allowing the API provider to track usage, control access, and enforce rate limits. API keys are typically included in the request header or as a query parameter. Important security note: never hardcode API keys directly into your abap code. Store them securely in configuration tables or using secure storage mechanisms. *HTTP methods. *Get retrieves data from the server. *Post sends data to the server to create a new resource. *Put updates an existing resource on the server. *Delete deletes a resource from the server. *HTTP status codes. HTTP status codes indicate the outcome of an API request. Common examples include *200 OK request was successful. *201 created *a new resource was created successfully, typically after a post. *400 bad request the request was invalid, example incorrect data format. *401 unauthorized authentication failed, example invalid API key. *403 forbidden the user does not have permission to access the resource. *404 not found the requested resource was not found. 500 internal server error an error occurred on the server. JSON, JavaScript object notation, a lightweight data interchange format that is commonly used in REST APIs. abap provides classes for serializing and deserializing JSON data. 2. Prerequisites SAP system and SAP system with abap development access. abap development workbench, SEAD for creating and editing abap programs. Authorization you will need authorizations to create and execute abap programs, including authorization to access network resources. Consult your SAP Basis administrator for necessary authorizations. External API access to the external API you want to call, including API documentation and a valid API key. Basic understanding of abap familiarity with abap syntax, data types, and object-oriented programming concepts. 3. Core abap classes for HTTP communication The following abap classes are essential for making HTTP requests. CL_HTTP_client This class is the central class for managing HTTP connections. It handles sending requests and receiving responses. You'll need to create an instance of this class to interact with the API. CL underscore HTTP underscore utility provides utility methods for encoding and decoding URLs. Useful for constructing query parameters. CL underscore XML underscore document, 4 XML APIs for parsing and generating XML documents if the API uses XML. We'll focus on JSON in this tutorial. CL underscore trex underscore JSON underscore serializer, and related classes provides functionality to serialize ABAP data structures into JSON format and deserialize JSON into ABAP data structures. This is crucial for interacting with JSON-based REST APIs. Note since ABAP 7.40 SP05, CL underscore trex underscore JSON underscore serializer is the preferred method. Older systems might need to use alternative JSON libraries or rely on string manipulation. Consider using the CL underscore SXML underscore string underscore reader and CL underscore SXML underscore string underscore writer combination as another option, available in older systems and potentially providing better performance. CL underscore ABAP underscore CONV underscore out underscore CE for character set conversions, example from UTF-8 to SAP's internal character set. Important for handling character encoding issues. CL underscore ABAP underscore CONV underscore in underscore CE for converting SAP's internal character set to a specific character set. CX underscore root and its subclasses, exception handling for handling exceptions that may occur during HTTP communication, example connection errors, timeouts, invalid responses. 4. Step-by-step code example, calling a JSON-based REST API with API key authentication. Let's create an ABAP program that calls a fictional weather API using an API key. The API endpoint is https://api.example.com/weather and requires an API key in the XAPI key header and the city as a query parameter, city equals London. Explanation of the code *. 1. Data declarations *. Defines a type weather_data to hold the parsed weather information. Declares variables for the HTTP client, go_HTTP_client, URL, LV_URL, API key, LV_API_key, response, LV_response, and the weather data structure, ls_weather_data. 2. Get_weather_data form *. Get API key, securely, this is where you'd retrieve the API key from a secure location, example a configuration table, secure storage. Do not hardcode API keys in production code. The example shows a placeholder. Use secure storage, if available in your version, or create a custom solution to encrypt the key in a configuration table. Construct the URL * builds the complete API endpoint URL, including the city as a query parameter. Create HTTP client * creates an instance of CL_HTTP_client using create_by_URL. Exception handling is included to catch potential errors during client creation. Set request headers *. Set_header_field, sets the XAPI key header with the API key. This is crucial for authenticating the request. Set_header_field, sets the accept header to application/JSON, indicating that we expect a JSON response. Send the request *. Set_method, sets the HTTP method to get. Send, sends the HTTP request. Exception handling is included. Receive the response *. Receive, receives the HTTP response from the server. Exception handling is included. Check the HTTP status code *. Get underscore status underscore code, gets the HTTP status code from the response. Get underscore status underscore text, gets the HTTP status text from the response. Checks if the status code is 200, OK. If not, it displays an error message and exits. Get the response body *. Get underscore text, gets the response body as a string. Deserialize JSON data *. Uses CL underscore trex underscore JSON underscore serializer to deserialize the JSON response string into the ABAP structure ls underscore weather underscore data. The deserialize method takes the JSON string as input and populates the ABAP structure. CL underscore SXML underscore string underscore reader creates an XML stream reader from the JSON string to provide an input to deserializer. Display the weather data *. Writes the extracted weather information, temperature, condition, humidity, to the output. 5. Alternative JSON handling, for older systems or better performance in some cases using CL underscore SXML underscore string underscore reader and CL underscore SXML underscore string underscore writer. This approach is often used in older SAP systems or can sometimes offer better performance depending on the complexity of the JSON data. It treats the JSON as an XML stream and uses XML processing classes to access the data. Important notes for XML handling *. Adapt XML path *. The key to the XML method is using the correct XML paths. Example // temperature, in low underscore XML underscore document dash get underscore value underscore of. These paths are like navigation instructions for the XML, in this case, JSON treated as XML. You'll need to analyze the structure of the JSON response from the API and adjust the paths accordingly. JSON nested structures will require more complex XML paths. Tools like online JSON viewers can help you understand the JSON structure. JSON structure * The effectiveness of treating JSON as XML heavily depends on the structure of the JSON. Simple JSON structures with key value pairs at the top level are easier to handle. More complex structures with nested objects and arrays require more sophisticated XML path expressions. Alternatives for complex JSON * If you're dealing with very complex JSON, consider using a third-party JSON parser that is specifically designed for ABAP, as these might provide more robust and easier to use functionality than relying solely on the XML classes. Character encoding * When working with the response text, especially if the API uses UTF-8, ensure you handle character encoding correctly using CL underscore abap underscore conv underscore in underscore CE and CL underscore abap underscore conv underscore out underscore CE to prevent data corruption. SAP systems often use different internal character sets. 6. Handling post and put requests, sending data to the API. To send data to the API using post or put methods, you need to 1. Create the request body, JSON. Build a string containing the JSON data you want to send. Use CL underscore trex underscore JSON underscore serializer, or the XML-based approach, to serialize ABAP data into a JSON string. 2. Set the request method * use go underscore HTTP underscore client dash request dash set underscore method, if underscore HTTP underscore request equals co underscore request underscore method underscore post, or go underscore HTTP underscore client dash request dash set underscore method, if underscore HTTP underscore request equals co underscore request underscore method underscore put. 3. Set the content type header *. Set the content type header to application/JSON. 4. Set the request body *. Use go_http_client-request-set_data, lv_JSON_data, to set the JSON data as the request body. Here's an example of a post request. 7. Error handling and logging ****. Exception handling ***. Use try, catch blocks to handle exceptions that may occur during HTTP communication. Catch CX_root and its subclasses to handle different types of errors, example CX_HTTP_communication_error, CX_HTTP_client_error. Status code checking * Always check the HTTP status code to determine the success or failure of the request. Error responses * If the status code indicates an error, retrieve the error response from the API, using go_http_client-response-get_text, and log it for debugging purposes. Logging * Implement logging to record API calls, request parameters, response codes, and error messages. This helps in troubleshooting and monitoring API integration. You can use SAP's logging functionalities, example BAL * function modules, or custom logging solutions. 8. Security considerations ***. Secure storage of API keys ***. Never hardcode API keys directly in your ABAP code. Store them securely using secure storage mechanisms provided by SAP or by creating a custom encrypted storage solution. HTTPS ** Always use HTTPS, secure HTTP, to encrypt communication between your ABAP system and the API endpoint. This protects sensitive data, including API keys, from being intercepted. Ensure your SAP system is configured to support HTTPS connections to the external API. Input validation * Validate any input data before sending it to the API to prevent injection attacks. Rate limiting * Be aware of the API's rate limits and implement appropriate logic to avoid exceeding them. Handle 429 too many requests errors gracefully. Data masking * If you are logging sensitive data, mask or encrypt it to protect privacy. Least privilege * Grant only the necessary authorizations to the ABAP program. Avoid granting excessive privileges. 9. Best practices ***. Modular design * Break down the code into smaller, reusable functions or methods. This makes the code more maintainable and easier to test. Configuration * Store API endpoints, API keys, and other configuration parameters in configuration tables. This allows you to easily change these parameters without modifying the code. Comments * Use comments to explain the purpose of the code and to document any assumptions or limitations. Error handling * Implement comprehensive error handling to catch and log errors. Testing * Thoroughly test the API integration to ensure that it works correctly and handles errors gracefully. Abstraction * Create abstraction layers to hide the details of the API integration from other parts of the application. This makes it easier to change the API integration without affecting other code. Asynchronous processing, optional for long-running API calls. Consider using asynchronous processing to avoid blocking the user interface. This can be achieved using background jobs or queued RFCs. 10. Advanced topics ***. OAuth 2.0 authentication * For more complex authentication scenarios, you might need to implement OAuth 2.0. This involves exchanging credentials for an access token, which is then used to authorize API requests. The CL_OAuth2 * classes in newer SAP systems can help with this, or you might need to find a third-party library or implement the OAuth flow manually. Handling large responses. If the API returns large responses, consider using streaming techniques to process the data in chunks. Data mapping. Implement data mapping to transform data between the ABAP system and the API endpoint. API management platforms. Consider using an API management platform to manage and monitor API integrations. Proxies. If your SAP system is behind a proxy server, you'll need to configure the HTTP client to use the proxy. Go_HTTP_client-proxy_host equals your.proxy.server. Go_HTTP_client-proxy_port equals 8080. If the proxy requires authentication. Go_HTTP_client-proxy_user ID equals your_proxy_username. Go_HTTP_client-proxy_password equals your_proxy_password, store securely. In summary, calling external APIs from ABAP requires careful planning, coding, and security considerations. By following the steps outlined in this tutorial and using the appropriate ABAP classes, you can create robust and secure integrations with external systems. Remember to always prioritize security and follow best practices to ensure the integrity and reliability of your API integrations. Consult the SAP documentation and the API provider's documentation for more information.